Hey guys, it's Professor Denton, Liberal Arts 2, Monday, Wednesday, Friday, 2 o'clock class. Hey guys, I appreciate your patience as we walk through this journey. Right now I'm in Tallahassee. I'm actually in a JBQ room at my church back home in Tallahassee. They're allowing me to teach via video today. Thank you guys so much for your support and your prayers. My mother-in-law is still in the hospital. We're still praying. A lot of you have reached out to me through email and on campus. So in lieu of Monday's class meeting, we are going to teach here on the board. So I appreciate your patience. We're going to do this in one take. So if I mess up, hey, I mess up. I'm human. We all mess up. So I'm going to do the best I can and appreciate your patience. Remember, you can pause, rewind if you get stuck, and be prepared for any questions on class Wednesday. We'll take the first 10 minutes of class Wednesday to clean up any issues that we might have. We are on worksheet number 4. This is in your workbook. I've gone ahead and drawn a sample Venn diagram. This Venn diagram has a universal set. It has sets A, sets B, and sets C. Notice that we have all 3 of these that are overlapping each other. So a lot of things to talk about. One of the things we talked about at the very beginning is when you have 3 different sets, 2 to the 3rd power is going to give us the number 8, and that 8 is the number of categories or number of subsets that we could potentially have. So you see we've got a category or subset here where all 3 are overlapping together. We have one where only sets A and C are overlapping, and we have a category or set here or subset where B and C overlap, A and B, the universal set, and then the empty set. So I'll quickly just count. We've got 1, 2, 3, 4, 5, 6, 7, and 8. Remember that empty set is always a subset of any other set. And I did some research on an explanation for you guys once we get back into class. So inside this universal set, we have 8 different subsets because there are 3 sets that we're looking at, A, B, and C. So 2 to the 3rd power equals 8. That just tells us the number of subsets that we have here. Okay. Now, if you take a look at your worksheet and the numbers that are listed, we've got the universal set, which has numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The best advice here is to start from the innermost circle here, which would be this category where A, B, and C all overlap each other. Are there any elements that are in sets A, sets B, and set C? And so as you look through the sets, A, B, and C, we see that the number 9 is the only element that occurs in all 3 sets. So it will be the only element inside this region. And then really from this point, as long as you do the 2 that overlap, it really doesn't matter necessarily the order. I'll look at sets A and C, which I believe sets A and C both have the numbers 1 and the numbers 8. So 1 and 8 would be in this category. And then sets A and B have 10, which are in both sets. And then we have elements. We'll take a look. Are there any elements that occur in B and C? So if you look at B, 2, 4, 5, 9, 10, and you look at C, 1, 3, 5, 8, 9, 11, we see that the number 5 occurs in both sets B and C. So the number 5 should be here in our chart. Okay? Now, we look and see, are there any elements that are in, say, set A only and not in any of the other sets? So I see that the number 12 is in set A. I see that the numbers 2 and 4 are in set B. And then I see that the number 3 and the number 11 are elements in set C and in no other elements. So I'll pause just temporarily as we kind of look at these numbers just to double check and make sure that we've got them in the correct sets on this Venn diagram. I'm sorry, let me make one correction. See, I told you I'd mess up. I knew I would. Let me make one correction here. The number 5 actually is in all 3 sets. As I just double checked my work and looked, I saw the number 5. So the number 5 actually should go right in here. I'm sorry, not in regions B and C. So I'm glad we did double check our work. Good teaching point there. Always check your work to make sure you don't make any mistakes. Okay. Now, as I look at this, are there any elements that were in the universal set that are not in sets A, B, or C? So we kind of look back through our data. I see the number 6 and the number 7 are elements in the universal set, not in sets A, B, and C. It really doesn't matter where we put those on the chart as long as they are outside of the ABC circle. So I threw the number 6 down here, and we can throw the number 7 over here. So this is a way to illustrate the sets, universal A, B, and C, constructing a Venn diagram. So this will be example number 1 on our worksheet. And again, you can pause the video, rewind the video, but I'll take a moment here, pause, just kind of look at the board here, just to kind of give you more of an opportunity to see where we've organized. So just to summarize this first part here, always start from the innermost circle. Where are the elements that occur in all 3 sets? Get those in. And I should have caught that 5 a little earlier. Then take a look, where are the elements that are in maybe 2 sets? We didn't have any here. Where are the elements that are in 1 set and 1 set only? Once we put those in, then we sort of branch out to the outermost part, and we notice that elements 6 and 7 were in the universal set, but they were not in sets A, B, and C. So this is example number 1, how to construct a Venn diagram using this data. Okay, so if you give me about 30 seconds or so, I'll kind of erase the board here. Not sure how far down on the video you'll be able to see, so I want to try to use the top portion here as best I can. Okay, so there is example number 1 from worksheet 4. I know you guys don't care about that extra stuff, but this is actually the room that I co-taught our junior Bible quiz team here at the church. Linda Walker and myself were the 2 teachers, so it kind of brings me back home a little bit and some of the church responsibilities I had. I'm curious, if we were having this in class, I would have asked how many of you did JBQ at your church if you were Assembly of God. I'm just kind of curious if any of you guys are familiar with what that is. But anyway, so a little intermission there. Let's take a look at example number 2. Again, recall from earlier, I mentioned 2 to the n power with our first example. So 2 to the 3rd power is going to produce 8 different groups. So this will be example number 2. And I'm not going to copy the Venn diagram here on the board because if you have the worksheet, and I can just kind of briefly show it here, you ought to be able to look into your workbook. I'm not sure if that's centered or not. But this is the example that we'll be dealing with here. But to see how it lays out the groups, there are 8 different groups here. And again, just a repeat, the reason there are 8 different groups is because 2 to the 3rd power, the 3 overlapping circles or bills in this particular example, produce 8 different categories. You have the one where all 3 overlap. You have 3 groups where there are 2 that overlap. Then you have bill 1 by itself, bill 2 by itself, bill 3 by itself, and then of course the empty set, which we talked about. The empty set is always a subset of any other set. Okay, so let's take a look at this example. Now, question number A says, which group is grump? Now, grump is a yes vote on bill 1. He is a no vote on bill 2. And he is a no vote on bill number 3. So what we are looking for is we are looking for grump to be located in a section of our Venn diagram that only occurs in bill 1, but not in bill 2 or bill 3. So he's going to be in a group that doesn't necessarily overlap with any of the other circles or any of the other sets. So if we take a look here at our chart, again, we're referencing the workbook here. I would say that grump is in group number 1 of our Venn diagram. He is in the location that does not overlap with bill 2 or bill 3. Remember, he voted yes to bill 1 and voted no to the other. Let's take a look at happy. Which group is happy? This is where I would interject during class one of those corny jokes that I think is funny. You guys probably don't think it's funny. But which group is happy? And not the people in the back of the room. They look painful back there. But anyway, sorry about that. I'm just trying to keep it light and fresh here as I normally do. Happy was a no vote for Bill 1, a no vote for Bill 2, but a yes vote for Bill 3. So again, kind of a similar situation. Happy is going to be in a set or in a circle on our Venn diagram that does not overlap with the other circles because they only voted yes on one of the bills in this example. So looking at our chart, I would say that this is group number 7. Group 7. Okay, example C. Which group is Terwilliger? Which group is Terwilliger? Terwilliger was a no, no, no. To me, he seems like the grunt, but anyway. Okay, now where would Terwilliger be? If you look at our Venn diagram, we see that groups 1, 2, 3, 4, 5, 6, and 7 are in the Venn diagram at a location that had at least one yes vote. So this sort of resembles the empty set. Where would the empty set be located? It's still inside the universal set, but outside of Bill 1, Bill 2, Bill 3. So Terwilliger is going to be group 8. Okay? Now, those are all the examples that are here, but I threw in a couple of other examples just to kind of, make it up and just kind of do some extra examples just to make sure. If I said where would the group be that was a yes, yes, no. Okay, so yes, yes, no. Which group do you think that would be? So I'll pause here. Again, you can always pause or rewind the video if you needed to, but I will pause here, give you about 10 to 20 seconds. Look on your chart. Where would you say the group is located that said voted yes to Bill 1, yes to Bill 2, but no to Bill 3? So it overlaps with Bill 1 and Bill 2, not including Bill 3. So a couple more seconds. And I would say that this is group number 2. Okay? And again, if you have questions about anything, write down your questions and kind of be prepared. We're going to spend those first 5-10 minutes of class on Wednesday. And I'll say, guys, if you saw the video, any questions from the video, I want to make sure that you guys move forward here. Again, just to throw in we're in Tallahassee visiting my mother-in-law. She's not doing well, and we're just kind of spending an extra day here. And but I didn't want you guys to get behind, especially with our building closed. We want to make sure we keep moving forward and we're holding class. I don't anticipate doing this much more than once or twice, maybe just today. And I look forward to seeing you guys back in class on Wednesday. Last example in this set, we've got a yes, and a yes. So where do you think on our Venn diagram the group would be labeled that voted yes, yes, yes to all 3 bills? So definitely there is some overlap here in our chart, but exactly what group do you think this would be? So we're looking for the section or the group in our chart, our Venn diagram, that has a yes, yes, yes to bills 1, 2, and 3. That would be the innermost group, which would be group number 5. Okay, so this will be the end of example number 2 on worksheet number 4. And again, we'll just kind of pause a little bit, give you guys an opportunity. I'll step aside. Hopefully I'm not shouting at you. I'm trying to make sure I talk at a comfortable volume that my video here can pick it up, and you guys can tune me up, tune me down, whatever is best for you. Okay? Any questions? All right, there we go. Since there are no questions, I'll move forward. But again, just remind me in class if you have any questions. This lesson is actually a really good lesson as it moves us into worksheet 5, the applications of Venn diagrams. So you're going to see a direct correlation between worksheet 4 and worksheet 5. So even if there are some struggles in the video today and you're kind of not understanding certain topics, I will be able to review most of these concepts as we talk about applications of Venn diagrams on Wednesday's lesson. Here's the goal for the week here. Monday of this week, we're doing the video. Wednesday this week, we're going to look at worksheet number 5. Friday, we're going to review anything that we've talked about in this unit with the breakup of the building and being out for a week. And we had some days off. We started class on a Wednesday. We had Martin Luther King holiday. So we've missed a couple of days here. And then Monday, I never liked the Monday test, but I've done them before. If we have to in a situation, we'll throw in a Monday test. My experience is most students don't struggle on a Monday test, especially if the content is comfortable, in which I think you guys are doing just fine. So we'll throw in our test on chapter 2, and that will be kind of our goal. I believe this is February the 8th, and so I tried to update MyMathLab, all of the dates in MyMathLab with the homework. Keep in mind that the homework for chapter 2, which a lot of you have already completed a good portion, is going to be completely due 11:59 p.m. the night before the test, which will be Monday, February the 8th. That's our goal, that's our plan. Barring any more building closures or any more travel, we should be good to go on that schedule. All right, last example here, example number 3. And again, this is the example that we are referring to. Not sure if this is centered or not, but this is the example I'm referring to. It's in your workbook, so you should have your workbook as you watch this video. And we're just going to simply go through example number 3 and then kind of close this out. So example number 3, we are looking for A with this symbol B. So just a review, we've talked about this before, but this symbol means intersection. Again, with intersection, we are only looking for the things in common between both sets. Only looking for the things in common. Where do they overlap? Where do they intersect each other? My advice for something like this is to maybe list out all of the elements in set A. So if we look at set A, we've got A, B, C, D, and E. A, B, C, D, and E. So these are all the elements in set A. I guess you could say A equals this. And then we've got B, set B. What are all of the elements in set B? Well, I see C, D, F, G, H. So C, D, F, G, and H. So here are all the elements. I guess I should separate those. So here are all the elements in A, here are all the elements in B. And again, the intersection, what do these two sets have in common? Well, I see C and D, C and D. ABE does not occur over here, ABE. FGH does not occur over here, FGH. So therefore, the intersection would be the elements C and D. And again, like always, your workbook should have the answers in the back. And if you take a look at the very back, I like doing this for some reason. But anyway, 3A, I don't know if you guys can see this. I'm trying to get it centered right. C, D, there's our answer. There's our result. All of the answers are in the back, and we can check over ourselves to make sure we are in the right spot. So that is example number 3. A, just a quick pause. Give you guys an opportunity. Again, you can pause, rewind the video. We'll change our colors. I'm actually enjoying the video teaching here, but I prefer being face-to-face. I like interacting with you guys. I miss you guys. Really, the tough part is I worked so hard learning all your names, and then we took a whole week off. Now I forgot everybody's name. So I'm going to try to relearn your names again next week. But anyway, let's take a look at example B. This time we've got A union with C prime. Now, another strategy, this was my first strategy, but another strategy, just kind of thought about this. You could potentially look at the chart and kind of cover up some of the things you don't need if you're looking for intersections and unions, and say, you could probably look on that first example and see, I can see where the A and the B overlap, and where they overlap on that intersection only has C and D involved. So there are other strategies. I just want to appeal to as many learners as I can. So here we've got A union with C complement. So union, we talked about this in class. The union is where you take all the elements in this set, all the elements in this set, and you put them together. Kind of like the marriage union. All of this person, all of that person, boom, comes together. All of your stuff, put it together. That's the union of the two sets. So, using the first strategy, example A, we've got, again, set A is A, B, C, D, and E. Set C complement, now keep in mind, C complement is actually all of the elements not in set C. It's all the elements in the universal set that do not occur in set C. It's basically everything else. So C complement would be A, B, C, and H. So again, if you look in C, we've got E, D, F, G, I, J. C complement is going to be everything else. So you could probably look at your Venn diagram, cover up your Venn diagram, just cover up C. If you cover up circle C, you're going to see A, B, C, H is the only thing left over. So that is what C complement is. Now, the union is all elements of each set put together. So the result or the answer here is going to be the set that includes A, B, C, D, and E, and then H. There is no need to repeat the elements. So as we see A, B, C here, A, B, C here, the only thing I need to make sure I include is I throw in H. So I've got A, B, C, D, E, and element H. Again, flip over, check our answer. We see the result is A, B, C, D, E, H. Okay, so that is example B. So I'll pause here. I don't want to get too low on the board. I know I said that earlier, but I just want to give you an opportunity. Again, pause, rewind, whatever you need. I'm going to take a quick pause here. This is our result. Hopefully you guys can see this. We're doing this one take. If it works, that's great. If not, we'll figure out what to do in class, and we'll just be flexible and adapt. Okay? I'll wrap up with examples C and D, and then we'll close this out. So example C would be the union of A and B, complement, intersect with C. Now this one's a little bit more complicated, but what I've already been able to tell from this group is you guys are a pretty sharp group. Working inside the parentheses, basically what we're going to do is we're going to do the union of A and B together. Then the complement of that is going to be everything else. Now this might be where the strategy of looking at your chart comes into play. If you take a look at your chart, and I'll try to hold this up here and see if we can make some sense of it like this. If you union A and B and put them together, you're looking at every element in A, every element in B. But if the end result really is going to be the complement, we actually want everything else outside of A and B. Well, if you can see here, that would only be elements I and J. So this first part, you can list out A, list out B, put them together, that's the union, and then take everything else to get the complement. Or you could look at your chart and see, okay, A and B together, but what's outside of A and B? The only thing outside of A and B is going to be I and J. We're going to intersect that with C. And I guess here at C, here's another strategy. Again, we can list out all of the elements of C if we want to, but here's the thing. Think of it this way. If we're doing the intersection, we want to see what they have in common. Well, if this whole side only has I and J, it's the only elements it has to offer to see what overlaps and to see what's in common. So if I and J appear over here at all, that's going to be my answer. How can I intersect two things and then have extra elements that weren't in both? So I and J have to be in both in order to be considered in the answer. So if you look at C, and I'll list out C, C has, I've got my notes here, E, D, F, G, I, J. E, D, F, G, I, and J. Okay? E, D, F, G, I, and J. So again, you see, if we're doing the intersection of these two, I, J, that's the only thing this one has to offer, so that would be the final result. So this is our solution. Again, flip over, check your answer, make sure we're in the right spot, I, J, and we've got it. Okay? So that would be example number C. Pause, rewind, come up with questions. Email me if you got questions. The internet is literally everywhere. So I am spending a lot of time with family. We're in and out of the hospital, checking on my mother-in-law. There is Wi-Fi in the hospital. So as you're sitting in the waiting room, I'm able to check emails a little bit here and there. So don't hesitate to email me if you have any questions. Last example, 3D. So we've got B complement union with C complement. So B complement is going to be everything outside of circle B. I'm going to use my Venn diagram here and sort of cover up B. And if I cover up circle B, everything else is going to be A, B, E, I, J. So A, B, E, I, J. Union with C complement. So when I cover up the C circle, I'm left with A, B, C, H. A, B, C, H. Union puts both sets together. They do not have to overlap. Remember the marriage union? You've got all of the females stuff, all the male stuff. They get married, they put all their stuff together. They got 7 couches they're trying to figure out where to go, but you put all their stuff together. They're union together. All their junk goes together. So we create our set. We've got A, B, and I don't have to repeat A and B twice in my set, but they occur over there. We've got C, so that one's there. We've got E. You don't necessarily have to go in alphabetical order, but I think for organization it kind of helps if we do go in alphabetical order. So we've got A, B, C, D, E, F, G, H, I, and J. So this is our set, the union of B complement and C complement. Okay. Thank you guys for tuning in. What we would normally do in class is I would have you do those classroom exercises, kind of like we've done before. So if you do those classroom exercises, they're found on page 77 in your workbook. I would encourage you to do those problems, bring them to class. Most of these, if not all of these, are odd. There's one even there at the end. The odd answers are in the back of the book. Feel free to check your answers and come to class prepared with questions. Don't just say, I didn't get it. Come to class with something like this. Hey, Mr. Denton, can you work page 77, number 49? That's the one I need. That's the one I need help with. Hey, when you were doing the video, you did example 3D. Can you go back through example 3D one more time? That's the one I was having trouble with. So don't come to class with just kind of like a vacant request. Come to class with something specific ready to go. And I appreciate your patience here and your diligence. Just a couple of reminders. Chapter 5 is our online chapters. I've had several students that have already done both tests and have done well on both tests. So I would encourage you to go ahead and knock that out, get that out of the way. I'm going to leave the due dates as is. So whatever I said the due dates for chapter 5 in our course chart at the beginning of the year, I'm just going to leave the due dates as is. But go ahead and make sure you complete the homework for chapter 5 and those tests. I had to make a small edit on one of the homework assignments in chapter 5, but I emailed that out to you guys last week. Feel free to email me if you have any questions. I'm excited to get back to campus and get back with all you guys. And thank you so much again for your prayers and your patience as we go through this. Email me if you have any questions. And that's a wrap. I hope this was informative. I hope we did well. I hope you guys could hear me. Hope you could see. And I hope some of you did JVQ when you were a kid. All right. Thank you.